Okay, let's start. We are almost on time, maybe a little late, but don't worry, we'll pick up speed. Anyway, my name is Govind Kotecha, and I'm a supervising engineer in Material Handling Group. It is a completely different type of group than you might have heard about up till now. I know you guys went through a very good training. You've been really going through a very, very fine training, and you got tremendous knowledge up till now. This is completely different than what you have seen before. So please be with me for, I would say, not it'll be less than 2 hours, or maybe even earlier. What we'll do is, because I want to be sure that we can get out, because there is a scouting people who are coming here and scouting some kind of group meeting and all that, so we'll be getting out earlier anyway. And I have to be going quick because I got a hot date, so don't worry about it. You guys want to go for a happy hour or whatever. Anyway, material handling, I'm going to put the next slide, which is good news and bad news both. One good news is we started about a few minutes late, so we'll have to pick up quick speed. The bad news, as you see there, that we'll go through 1 hour about or thereabouts to give you an overview of material handling equipment which is used in the industry today all over the world. And the second part will be a short one, and then we have a break at 6:30, but we might take it even early if we finish early. And then we have the second part, which gives you the idea of material handling projects which are in-house today, which we handle. So that gives you an overview of the total industry and what we have today in-house. So, and also the last part, which was the bad news part, is at the end of the presentation I'll have a quiz. It is not to trick you, it is very simple. Every answer is there when you see the slides, so don't worry about it. It's a very simple quiz. But that's the bad news, and after that, and it won't be taken here, we just take it at home, so we can eventually give me or send me an email or whatever you want. Anyway, so what we have to do first is our safety moment, and I gave you a handout. The thing about this is, if you all remember a long time ago, we had, when we went to a station, to fill gas, they were called service stations. And service was, they give you service, they provide you service, they fill the gas for you, they change your oil, they wash your windshield and all that, which we don't see anymore. What do we call them? Gas stations. So only thing we get is gas, and the service is gone completely. So all of us go and fill up gas once a week, sometimes twice a week, depending on the number of cars you have or how much you drive every day. And this is something which is related to our pumping gas every day or every week or whatever, whenever we go there. And equipment, Petroleum Equipment Corporation or the group, Institute, they did a study about the pumping gas and static electricity and fires. So there are always that hidden danger of fire when you pump gas. What they are saying is, this institute, they came up with a big study, and some of the findings are funny, they are laughable at times, or I think some of them I don't even believe, but it depends on how you look at it. What it says that when we go and pump gas, and if during pumping gas, if you have any static on your body, which normally happens when you go in the car while you're pumping and get out of the car and go near your nozzle, there is a static charge, and then the vapors ignite. And this picture you are seeing is a car which actually, well, you can see how badly it is burned up. And that happens, and it's a continuous problem with everybody when you pump gas. Be careful. Now, according to their results, you can see they did the study, and they're saying out of 150 cases, and I think I don't believe this much, but it is sometimes laughable too, all of them were women. No, why would women only will have it? And that's sometimes, I think it's take with a grain of salt. But the second thing they said, that it happens when you get back to the vehicle, and when you come out and you're pumping still there is some static because you entered the vehicle, which is warm inside that, and you're wearing rubber shoes or whatever, that is a good chance of having a static charge. And when you go next to your nozzle, and you can see that there's a fire. The other thing they found out, they said, was most of them are rubber sole shoes. Most men never go back to the car. And this is also another interesting study. I don't know why it is, but normally men, if you think yourself whether you really go back to the car once you start pumping gas, you don't go back as a man. Women normally have a lot of other errands to run, so they might just go back to see something, get a cell phone out or whatever they want to do. Other thing they're saying that please don't use the cell phones because cell phones can have static. So that's another possibility there. And they said that 29 fires were not because of any particular car, all kinds of models have, because it's not related to the model of the car, it is related to the static charge. And the other fires they talk about is even before you start pumping, you just go and open your cap, and because there are vapors and you already have static charge on you, it might ignite. So the rules they are giving is, first of all, don't go back. When you start pumping, don't go back to your car, and don't enter the car. Second rule they are saying is that if you do go, touch some metal before you reach to the nozzle, so that you've got the static out, your earth heat already is gone. And I have a metal key, so what I do is I just touch, if I go in, normally I don't either, but if I go, I just use the static, your key next to your handle, and then you go to the nozzle, so you already release your static charge from your body. And this information is all on the website. I've got the website there. You can go there and find more studies they have done about static charge and fires. One last thing about this is, please pass this on to some family members. And it's summertime, all of us travel, and we are always on the road, and we just go and pump gas, and we forget because so many things on our mind. Kids are in the car, and they are cranky, and all that. We forget it. And be careful that it doesn't happen. We just pass it on to people and say, be careful about the static charge. One thing, just on the 4th of July weekend, we were coming back from San Francisco, and we stopped at one of the gas stations about 100 miles towards almost from LA. And I was surprised to see on the pump, as soon as I got out, I just saw on the pump a big sign saying, stop your engine, and be sure when you're pumping, don't go back to your car. So they have started putting these signs everywhere, which is interesting. I didn't see many here. I don't know whether you guys have seen or not, but I don't see it. So main thing is just be careful, drive safely, pump safely, and hopefully we don't get a fire at all. And that's the main thing. Anyway, now we go to the next part, and what I'll do is I'll give you some introduction about material handling, and also how material handling fits into the company. How do we fit? Okay, this is you might have seen this slide before. The total company. We have the top. We've got the general manager Chris Ashton, and then we have all these different groups here, different offices. We have an office on the left side here. This part is the support group for the operations. This is the Arcadia Monrovia operations. Then there is a Martinez, Long Beach, and COMEX is a part of Long Beach now. Now, this operation here, Arcadia Monrovia, as you know, there are 3 Monrovia offices already. I mean, 2 of them are there, and third one is coming up. One is the one right of us, right on the west side. One is 222, and 605 is opening up for Chevron jobs. So they are going to be all gone there. So we have all these operations going on, and this group here, which is where we guys, all of us, all the engineering group falls under here. So we come under Carl Sale. Of course, we got a process group under Helmi, and then we got the other groups, which is a procurement, and Dave Reynolds and all that. Now, we all fall, as I said, under this group, Carl Sales group. So, okay, where do we fit in our groups with all the engineering groups? That is the engineering department there, and we have mechanical, piping, architecture, structural, electrical, instruments, CAD, and IT. And in the mechanical group, we have rotating. You heard from them. You heard from quite a number of them. You heard from process guys, rotating equipment. You heard from vessels. You heard from mechanical utilities, heat transfer, material applications. And today, you got the last guy, who is the material handling guy. Now, material handling, as I said, is a very specialized area. There are only very, very few people who have expertise in that. And presently, I have some help. I'm alone for the time being. I have help. I got Jeremy, probably you might know him. He's a young student from college, and he's doing a summer intern, and he's helping me in developing a acquisition. I have another designer, which I'm going to recognize at the end. He's helping me part-time. But the rest of the time, we really support every project. Whatever you see there, we support everything. So now where do we interact? We interact with all the mechanical engineering disciplines, which is all these guys. We have process engineering, we work very closely with them. We have piping, instrument structure. I didn't mention more, but all these guys, if you see there, all the engineering disciplines. We have project management, we interact with them, project controls, QA, QC, document control, procurement, construction site, all the West Coast offices, which is Arcadia, Monrovia, Martinez, Shell Martinez Refinery, Tesoro, Wilmington, it used to be Shell Wilmington, Long Beach, and Calgary. So all these groups we have to interact, we have to support, it's a support group basically. We support any project which comes and happens in any of these areas, and that's where we fit in. Anyway, this gives you just a general idea of where we fit in and how it all works. Okay, now what does material handling do? And what is material handling? Okay, if you think of, like most of our jobs up till now you've been listening or working on are petrochem, chemical plants, refineries. In a refinery, you heard from all your experienced people who came and talked to you that if there is a pump, the pump would move liquids. If there is a compressor, the compressor moves gases and vapors. If the pump guy, the rotating guy, cannot move it, or the compressor which is rotating also, if they can't move any material, it comes to us. We move it. So anywhere when you hear from now that there is something which is not a liquid or a gas or a vapor and there is some handling to be done, it comes to material handling group. We support that project. There are always little things. We'll come at that. Like the second part, I will show you where some of the projects we are supporting and how we support them. So this gives you the idea of what the material handling group does. We do the preliminary process studies, so we work with process guys, preliminary PNID, which are PNID guys, equipment selection, we do the selection for them. We develop all the system specs, develop equipment data sheets, write equipment requisitions, conduct TVA. This is the technical bid analysis. Write conforming rec, then review vendor documents, coordinate interdisciplinary vendor documents, construction and field support and project checkout, all the way to the closeout of a project. So what it does is, I don't want to bore you with too much of making you a material handling engineer, but I want to tell you that all these things are done and all the groups are connected, so how you will fit into the material handling group, if there is any work on material, you will somehow hear, or you'll have a need to come to us, we will have need to come to you because we interact with everybody. When I show you the industry equipment, you will see that there is a lot of interaction between every one of your disciplines. Okay. Solids, material handling, solids handling. I picked up a very soothing background, if you see, because it's late in the day, your eyes are tired, so you wanted to see some nice soothing water, Pacific, think about swimming or going to the beach or whatever, and most of the slides have that background, so it is real soothing for you. Anyway, I will just do a little thing here. When it says solids handling, I have this package in my hand here. Okay, it is going to be moved. And I'm going to move it. I moved that. What type of force did I use? There was some force which brought it there, from here to there. It's a gravity. Material handling has a good friend, a gravity. Everything which we move, there is always some gravity involved. When we go into the equipment, I'll show you, there's somehow we are using gravity. That means you use less power while you move that thing. And that's helping us because gravity is always helping you. The second thing, when you have a friend, which is a gravity, you will have some negative part, which will be a foe. Will be somebody who is against you all the time. And so material handling engineers have to help. They get the help from the gravity, but we have an environmental hazard when you drop material. There is a chance any solid material when you drop, you go to some conveying systems and you'll see it. there is dust there. Dust is the biggest environmental hazard, which we have. Material handling engineers have to worry about the dust in every design, every system we work with, and that is an environmental hazard which we always have to mitigate, and you have to be careful about. Whenever you think of a system, you have to work with it and work with how to mitigate that. Okay, I wanted to start with the basic P&ID and process group. Now, I don't know how many process guys are here, or process and P&I. I just want to get an idea of people so I know. Okay, we got quite a large turnout. How about the piping? We got piping. How about structural? There you go. We got structural too. The electrical. There is one there. Instrument controls. Okay, that guy is not there. But so when I come to those slides, I will speak less. But at least good for you to know that we interact with them too. And of course, we've got mechanical group, we've got rotating. I don't know whether it is from rotating anybody, rotating equipment. Vessels, you're rotating? Sorry. Vessels, I think we got a number of people, here, and I can recognize quite a number of you. We also on heat exchanger, anybody? There you go, that's heat exchanger. And how about utilities? We got Victor, and there are two. Yeah, Ted is there. Anyway, as we go, you will see that we'll be interacting with all of you. Every group of engineering will be interacting. The main thing I picked up this one because there is the beginning of a job. When we start a job, always you have process people, P&I, process group. They are the first one to start. Maybe they are doing a study. They're starting a process flow diagram. They're starting the P&Is. They always, if there is any material handling involved, we interact very closely with them while they are making the P&Is, not that they have made it, when they are doing it. So what happens here is when there's a lot of interface between the two. Whenever there is any particulate material in any process, if you see a catalyst there, you get fertilizers, polymers, byproducts such as coke, solid sulfur, etc. Solid handling engineers are involved. So we get involved with all that. There is a constant flow of information between us and them while they are preparing their P&Is. And this works of the process engineering department in the area of solid processing varies considerably from the work we do in your process plants, which you are used to. So that's what we normally do with refineries. Let me give you at this point something interesting about the company. Now, I know Victor probably mentioned to you that we are growing very fast. But when we had, Chris Aston had that presentation, all hands meeting, he did mention that we are very heavy on refining. And which is a fact, because you see all the jobs we have, and which we'll talk about some of them. Most of it is based on refining, petrochemical, we don't have much, but refining a lot. And they want to diversify the company. Because we are growing, we need to diversify more into other jobs, other type of industries, other type of projects. And what they mentioned that time, and if you remember it, he said that we would go into power group, our power type of jobs. We go into minerals, which is another area we might go. And we'll go into infrastructure, which is something which old Heritage, Parsons Heritage is doing. I think we have a contractual problem with them, not a problem, but a requirement, sorry, that we cannot compete with them for X number of years. So we can't take that type of work which they normally do, which is Pasadena office. So eventually we will go there. Now, when we go there, eventually when we get the jobs on those areas, which is power, minerals, and the facilities groups, you will see a lot of material handling, because there's a lot of material handling in all those areas. And so you, as you grow in the company, you'll be here 10, 20, whatever years, 30 years, we don't know. But that day is coming that when we diversify into other projects, other groups would be involved, and material handling would be heavily involved too. Okay, another slide here which tells you that fluid processing plant, what happens when you do a P&I, the P&I started, you buy equipment which you have all heard up till now. There's a vessel there's a heat exchanger there are pumps there are compressors there, all kinds of equipment. They can make a P&I with that because we have been doing so many of them. But if there is material handling involved, they cannot do it right away. We have to follow, and our group is the knowledge and all the experience which you will see, which is here, is so broad It is the width of knowledge, not the depth of knowledge. So width-wise, we will cover a lot of things which you will see, which is not easily available to a process engineer or a P&ID engineer. So they have to work with material handling, and we have to work with the supplier of the equipment. So we work a lot with suppliers, and we get a lot of information out of them. And once we get that info, it is gone to the P&I to make the P&I ready. So if you see that there is things like all these items are very easy. They can make a P&I. But when you go to solids processing, we depend on the information which we get from our suppliers. We can determine sizes from conveyors, bucket elevators, filters, blah, 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 because they are in the catalogs. But when we buy systems and we have something like dust collectors, blenders, dryers, etc., there is a lot of information which is specific to that vendor. Until we get that vendor info, we can't start the layout, we can't start the floor plans, we can't start the P&Is, we can't do anything. And all that information has to flow between us and P&I people all the time. And that's where we finally get the P&I done. You know, if you don't have the selection done, what it says here, which is very important for you to see, that if we don't have the preliminary information and the outlines, we will have a lot of P&I issue recycles because the information was not there and they did not pick it up and we did not have it, so that we are not involved or whatever. And that becomes a big issue because when you go on recycling P&I, it's all man hours, and our client won't like it. Okay, depends on the supplier outline drawings are very important, as I said before. System engineers draw system. When I say system, it's P&ID. So this is one of my company acts where I used to work. They used to call them systems. So sometimes I use, and bear with me with some of the slides I might show. They are very old. I had to dig into my garage and the boxes to find some slides. So some of them are very old documents which we made slides out of. So they might be a little bit poor quality, so bear with me on that. But the information is there for you to learn. Okay, we have a close liaison with our P&I guys. Okay, then we'll go into the different code of accounts, but I will just go to the next slide. Okay, the most of complex systems which we buy, which is mentioned here, the complex system we buy is coke handling system, sulfur handling system. These are not one piece of equipment, they are whole systems we buy. And that's where when you buy a system, you definitely come across every discipline. We work with the piping guys for the layout work, we work with the process P&I, everybody. We have electrical equipment in there, we've got controls there, we've got instruments there, we got a lot of structural supports which we need. All that system has to be completely fed by all the other groups like you guys coming from. Well, let's go to the next slide. This is the information which flows from the systems engineer, which is P&I engineer, to the solids handling engineering group. With all the operating conditions, they know exactly what are the pressures, operating pressures, temperatures, rates, viscosity, also the design conditions, the pressure, temperature, all code requirements, the dust loading. I mentioned to you our biggest enemy in the material handling is dust. Every time there is material handling, there is dust somewhere. And we want to be sure that that doesn't become an environmental hazard. So we always have to handle that. And the steam, pressure, drop, blah, 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 physical properties of solid particles. Now this you might hear some of these words, but I'll just tell you. Particle size, because every solid particle is all dependent, the design depends on the size of particle, what size the particles are. Then we got size distribution, bulk density, specific gravity, moisture content in the particles, angle of repulse. This is a very interesting one. I'm going to touch it when we go to some pictures, and the hardness of the solids which we handle. All this information usually flows from process engineer to the system engineer to the solids handling engineer. When we get other data also from them is particularly more important for P&I guys, the insulation requirements. In case we have high temperatures which we are handling some material which is high, which will come to one of the projects. So we have to be sure that we know all the insulation requirements, and that goes onto our P&I. Okay, this is information from the solids handling engineer to the process and the P&I engineers. We have the power. Every equipment will need power. As I showed you, we are not always lucky to have our friend, the gravity, just everything is going to be handled just downwards. We have to go upwards too, and we have to use all or we have to rotate some equipment. Because a lot of things happening, and we need power. So all the motor information and all that, which power requirement, we give it to them so that they can use it to make their input into their motor lists. We also have all the utilities which we need in our equipment, in our systems, so that they can make the utility flow diagrams. We also have, you should check back, also we write the spec, so they get all the information from us. And size and shape, the shape of equipment is very important because it takes real estate. When you say column, I mean, all of you have a picture right over here. There's a column. Okay, we're going to go up like that. There's so much wide, so much high. But when you talk of a bag house in a material handling equipment, nobody knows what shape it is coming. There are so many different ways you can have a bag house. So we have to have actual physical drawing to give it to our piping friend here and say, hey, this is what it's going to look like. Put it on your plot plan. See how much of real estate it's going to take. Okay, we talked about equipment layout, and this is all depending on the plot plan. We talked about that. Okay, these are some of the P&I guys, more so, and process guys, and of course all of us. When we see a P&I, we normally don't see all this, not too many of these, but just to give you a quick flavor of some of these P&I, the flow diagram symbols are like here. If you see something like that, that's a slide gate valve which stops the flow of solids. This is a hand slide gate. This is, of course, the gate operated by cylinder operators, so there could be either air or liquid here. This is a rotary valve, which is a sealer for the process. This part upstream is the process pressure side. Downstream is the environmental outside, or it could be a downstream equipment which is low pressure. Then we got all these other equipment, so I won't bore you with this, but this is all in my slideshow there, so you can see it. Okay, the commodity codes I'm going to talk about now, we can flip that because this is basically saying these account numbers which I've shown there, it is not used by our company. It is from company X which I worked for, but basically it gives you the different flavor of what do we have. In one of their accounts which says solid transporting equipment. So where you want to transport solids, we have things like, most important thing which you probably know about is belt conveyors. We have bucket elevators. This is where we actually go up and then you drop down because you're using your gravity afterwards. These are chutes which are very important on your angle, what angle you have your chute, which is very important for the piping people. Then we have something interesting here you might remember, pneumatic conveying system. I'm going to touch a little bit more on this because many places we are having powders, and I'll come to that when we come to those areas, that we are supporting a company here that is called Criterion Catalyst. All the refineries use catalysts. To make the catalyst, we have powders in it, and we have to handle the powders, and that's where your pneumatic system, which is driven by air, it works, the whole system, it moves from A to B by a pneumatic system. And we'll talk about that. Unit 172 code, which says storage. So once you handle them, then you have to store it. We store liquids, of course, in tanks and tank farms. Here we have giant silos, big hoppers, all kinds of things, which we'll look at some pictures very shortly. Then we have size reduction and enlargement. Size reduction, most of these which you see here is not used by us in chemical industry, but they'll go into mining. So when we go into minerals projects, hopefully eventually, then we'll be seeing all this equipment there too. And you go to next codes. We have solids drying equipment because there is always some drying to be done in the solids. And there is weighing and packaging. You go to a Home Depot and you want to buy 25 pounds of fertilizer to go into your garden. You want 25 pounds, and you go there and you get exactly 25 pounds in a bag. How does it happen? We have a complete system of weighing and packaging equipment which goes into picture, and that's how you move that. You move from the store into your car to the house. It is all solids handling. You are handling solids somehow, and it has to be packaged, and this is where this type of equipment they come into picture. Then there is a separation of different kind of solids. We have solids which are very heavy, which are lighter. The dust is lighter than the other particles, so we have to separate them out. And that's where this kind of equipment will come into picture. We have classifiers, we got filters, we got most interesting one here, I think, is the centrifuge type of classifiers. Then we dry suppression and classifying equipment. We have got a number of things, the filters there, the wind vent filter. Now all these things is very alien to you, but I'll show you the pictures very shortly, and then you start all gelling in. And then other solid handling equipment we'll talk about, and you'll see a lot of these equipment which I'll show you. Okay, the first code when we saw it was solid transporting equipment, and in there we have air conveying system, which is a pneumatic air conveying system, and bulk material conveying. So let's see. When you talk of pneumatic conveying, there's a number of things happen here. We could move material from A to B in so many different ways. Well, but basic systems are, it's a vacuum system or a pressure system or a combination of vacuum and pressure. We always use any one of those. And what happens here is you take like a rail car, this is a railroad car or a truck. You want to take the material from there, you go up to the receiver here, and this is where our culprit, our